Okay, so the next question posted in the channel is this: two particles each of mass m and velocity v. You see, mass m and velocity v are moving as shown in the diagram. Okay, same direction along two parallel lines. Everything is given in the diagram here. A and B are 2 points on the line of motion, and point C is the midway. Midway means, so here it is d by 2 and this is d by 2, midway. Okay. What is it? Midway between the two lines as shown in the figure. Read the following statements. We have to verify each one of the statements. This statement is the magnitude of the total angular momentum of two particle system. Again, this problem, I think I have discussed it in the rotational motion chapter. You can check the videos, the YouTube. Now, so here I need to find total angular momentum. There are totally two objects here. So there'll be L total will be angular momentum due to individual particles, two particles. Okay, and remember angular momentum is a vector. You need to be careful. And how do you calculate angular momentum? L is equal to I either do RP sine theta, or I can say R perpendicular into P, depending on how it is. So you see that here the momentum is in this direction. Oh my God, 1 second. Here the momentum is along this line. This is also momentum is along this line. Okay, so let's say P vector. Now what is happening is I need what I can do is I can find R perpendicular into P, where R perpendicular is the perpendicular distance about the point. In the point here around point A will be MVD. So about point A they are asking. So let's find the total momentum about point A. Let me write down. So angular momentum about point A will be equal to angular momentum of the first particle about point A, angular momentum of the second particle about point A. This is R perpendicular, this R cross P. Okay. And again, R perpendicular P, you see the vector direction will come from clockwise, anti-clockwise. Watch the videos available in the playlist. So R perpendicular, you see, look at this. I'm going to find about point A. So point A is here, P vector is here. The distance, the R perpendicular from point A to this vector is 0. So R perpendicular is 0, this term is 0. For second point, L2, for this vector, the R perpendicular will be the perpendicular distance between the momentum, this green line, and this point A. Perpendicular means this. You drop the perpendicular, this is R perpendicular. If you want, you can say R perpendicular 2 and 1. This R perpendicular 2, which is just the distance D. So it is D into P is MV. Okay, and MVD, and you can see that about this point, how is this particle moving? Momentum is this way. So if it's like this, let's say you tie this particle down with a string here of fixed length, the particle will go in a circle in this direction, which is the anti-clockwise direction, which is positive again. For more clarity, watch the videos. So this is plus MVD, and what they're saying, magnitude of total angular momentum of the two particles around the system is MVD. This is right. So first one is correct. I hope this is clear. Okay, we have to check the next one. So I'm going to erase this. We are going to check the next one. So the magnitude of total angular momentum of the system around point B will also be MVD. You see, if you look carefully, point A point B symmetric fully. So whatever calculation I did for point A, exactly same thing can be repeated for point B. You'll get the same answer. Okay, so point B, if I find, you will take this as R perpendicular. That is from here to here. This is R perpendicular, still the same P, perpendicular distance is D. So you'll still get the same answer. Whatever I got here, same calculation, it can be repeated. Okay, point A and point B are exactly symmetric. So this is also correct. So first one is right, second one is right, third. The magnitude of the vector sum of angular momentum of the system about point A and B shall be 0. Okay. So vector sum of angular momentum around point A and point B. Okay. Of the system, which means fully. So what you have seen is angular momentum about point A. Vector was MVD plus. Okay. You see when I write vector, when I say plus, it's K cap. Watch the videos. Okay, and LB, remember LB means about this point. So angular momentum of second particle will be 0. Of the first particle, it will be moving this way, right? This is the P vector, this is the R vector. And again, if you tie it down, the particle will go in a circular motion in this way, which is clockwise. So it is minus MVD. Clockwise is negative, anti-clockwise is positive. So the total vector sum, the magnitude of the vector sum. So vectorially, when I add, obviously it's going to be 0. Okay, it's plus K cap, minus K cap. So third one is also true. Okay, this is plus MVD, minus MVD, and this is 0. Next, last one. The magnitudes of angular momentum of this of the system about C will be 0. It's actually the word about is missing. Okay, about point A, about point B, about C. So now I have to repeat the calculation. Same thing about C. So you see, I have one momentum vector along this direction. Let's say P1 vector. Second momentum vector in this direction, P2 vector. About point P means total angular momentum. L total about C is equal to L1 about C plus L2 about C. R perpendicular P1 plus R2 perpendicular P2. Okay, what is R perpendicular? From the point, because they want about point C. And the point this P1 vector perpendicular distance. Either D, so this distance will be D by 2. Adhe mari in the perpendicular, you take this perpendicular, so this distance will be D by 2 because it's about point C. Okay, R1 perpendicular, this is R1 perpendicular D by 2. Momentum is mv. And what is R2 perpendicular? It is D by 2. Momentum is mv. Again, careful, vector ilya. So you have to think. One rule da. If you want more clarity, watch the videos about this point. If I tie this particle here, it will go in clockwise direction. Clockwise is negative, so this is negative. And second one, if I tie this string, adhe mari inga kair katti virringa in the particle, it will start moving in the anti-clockwise direction, right? Momentum ipdi sutta arambikum. Okay, so anti-clockwise is positive. So obviously you can see they add up to 0. So the L total vector sum is equal to 0. The magnitude of the angular momentum of the system is mottama is 0. This is also true. So all the 4 are true. Again, I have explained it. More clarity the entire videos on all the chapters available in the YouTube playlist. 11th rotational motion videos paranga. I would discuss this better, and I would have taught you how to calculate angular momentum and torque. Okay, so if you have more doubts, Telegram channel, you can post it. Any more clarity you want, watch the videos and keep practicing. Pudichirundha videos like pannunga, inform all your friends so that it will be helpful to all. So see you.